When someone says, "Our brains are being manipulated," we usually picture scenes from science fiction: chips, computer viruses, evil scientists. Yet nature solved this problem long before we did. Some microbes intervene in the nervous system with a level of sophistication that rivals the boldest dreams of modern pharmacology. This is what a story reminds us of, one in which the protagonist is a tiny but remarkably cunning parasite, Toxoplasma gondii. This microorganism can reproduce only in the intestines of cats, and yet it manages to reach the brains of many mammals, including humans. It crosses the blood-brain barrier, that biological firewall meant precisely to keep intruders like this out. The parasite's ideal script is simple. The cat becomes infected, the pathogen exits through the cat's waste, a rodent ingests it, and then, here comes the real trick: the infected rodent is eaten by the cat. The circle closes, and the parasite is back where it can reproduce. The only problem is that rodents are wired to avoid cats. Toxoplasma's answer is almost chilling. It rewrites behavior. Its cysts target specific regions of the brain that regulate fear responses. They don't simply wreck everything in their path. It is as if they know exactly where to touch. The infected rat no longer fears the cat. In fact, the smell of cat urine becomes strangely attractive. The parasite does more than mute fear. It activates neural circuits linked to sexual motivation. The inborn flight response is reshaped, guiding the rat precisely into the kind of situation where its life is likely to end, but where the parasite reaches its goal. While industry pours billions into drugs designed to reduce anxiety, influence the stress system, or increase libido, Toxoplasma accomplishes all this without side effects, exactly where and how it benefits the parasite. Many of those costly research efforts have failed. The parasite, meanwhile, executes its program flawlessly. And it is not alone. The rabies virus targets neural networks responsible for aggression. The infected animal becomes more likely to attack and bite, passing the virus on. Other microbes have developed similarly refined strategies. If a hacker manipulated a corporation's computer system the way these organisms manipulate brains, we would assume an insider was at work, someone who knew every line of code. The parallel is unsettling and astonishing. These microorganisms do not think as we do, and yet through evolution they have acquired a near handbook understanding of mammalian brains. They seem to know exactly which switch must be flipped so that the host's body and behavior serves their purposes. The deeper message may be this: in nature, there are no unnecessary tricks. What survives, works, whether we like it or not. And when we realize that even a single microscopic organism can subtly bend the direction of our thoughts, desires, and fears, we begin to see ourselves in a different light. We understand that the mind we take to be wholly our own is sometimes the stage for forces we barely comprehend.